Hey guys, welcome back to coding asteroids in TypeScript. Today we're going to take a look at polygon-polygon collisions. So these are the collisions that will be used for asteroids colliding with the player ship, or asteroids colliding with the saucer, or the saucer colliding with the player ship. Right, all these combinations. If you're not aware, I did a video on separating axis theorem. That's the algorithm we will use for doing the polygon-polygon collisions. Yeah, feel free to take a look at that. I also linked an article in the description below that also goes over the separating axis theorem. All right, let's jump in. This is where we left off last time. I'm just gonna go back to my code editor. And the first thing we want to do is we want to have something to visualize, similar to how we did the point in polygons collisions. We just drew a polygon and we just drew a grid of points and test if that point is within that polygon. We just mark it with some color. We want to do the same thing with polygon-polygon collisions because it's just a similar concept, but instead of drawing each point and testing that with a polygon, what we will do is we'll take each point and then create a polygon there and then test that polygon with the other polygon. So it'll just be a grid of polygons that's colliding with another polygon, right? Okay, so first thing I want to do is we want to go to game. We can do this experimentation there, and I want to have a polygon. So let's create a polygon. We'll just put it here. I'll say polygon A is a polygon. Import that, and then I'll initialize it here. Say this dot polygon A equals new polygon. I will give it a new position. This will be, I don't know, 300, and you need a list of vertices. So I want to have just a simple triangle. Let me just come up with some vertices. So I will say new vec2, maybe -7, -5. I'll just go clockwise. So we have new vec2. Now I want the top right quadrant, so it will be maybe 10. Wait, so y is going down, so this is the top left quadrant, and then I want to go to the top right quadrant, so it will be, let's say 10 - 10, and after that I will do new vec2, both positive, maybe 5, 8. Okay, let's draw this polygon, see what it looks like. We will say draw a shape. Okay, so this will be context, and the shape position polygon.pos, and you need to pass in the vertices, geometry. Okay, let's see what it looks like. Okay, we have a triangle here. Okay, let's make it bigger. So we will do .map v.scale, we'll do 2. Okay, let's make it even bigger, maybe 5. Okay, now let me just get rid of that asteroid, and so it's not distracting us. Okay, now let's bring back our draw debug grid, and I will say this dot polygon A dot position a point, and what's happening? Do I not have this anymore? I do. Let me just import it manually. Draw debug grid. And then, yeah, so instead of taking each point and then testing that, we want to have a new polygon at that point. So maybe we can just create a new rectangle. I just want to create an inline maybe here. So let's say let rect is equal to just some vertices. We can say new at 2, 5, 0, new at 2, 5, 5, and then we can do 5, 0, and then we can say 5, 5. That's fine. Now we're gonna go negative. Now we want to go both negative, and then we're gonna do positive, and then y negative, and then we want to do, are we back yet? Let's see, minus 5, 5, minus 5, minus 5, and then 5, minus 5. I don't think we need this one. Okay, so now I want to create a new polygon. Let test polygon equals new polygon. It will be the point position and vertices are rect, and I'll do, yeah, that's fine. And then we want to check, we want to create a new function called are polygons colliding. Then I will say test polygon and our polygon that we drew earlier. Right, now let's create this function. So we will create this in the collision file where we had the point inside polygon. Yeah, after that let's do this one, export function are polygons colliding. Now this will take polygon A, polygon B. I just want to say AB, it's too long. Okay, take 2 polygons. Now in here we want to implement our SAT. Right, so let's first test what happens if we just return true. We should see all green. Okay, why is it an error? Let's go back here, import that. Okay, yeah, everything is green, makes sense. But now these are not points, these are polygons. So let's not draw them as circles. Let's do, what was I drawing here before? Oh, they were rects before. Yeah, that's okay. It just looks like points, but these are actually polygons, and the size of them, we can't see the size. I think once it starts colliding with the our fixed polygon, maybe we'll start seeing the boundaries of those polygons with the color. We can also have another polygon and then move it with the mouse and test it. I think we can do that as well at the same time. Yeah, let's do that now. I can just do that here as well. Similar to this, we will say mouse move and have a point here. We can say mouse position, and we can say a point, a vector, right? And then we can say this dot mouse pass is equal to vector dot 0, and then every time we do a move we want to calculate that offset. So first what we need to do is we need to get the canvas. We need the bounding rect. We can say construct is equal to canvas. Do we have access to canvas? No. Let's import that from our view. Does view expose canvas? No. So let's expose it. We can say canvas, and then we can import it here. Say canvas dot get bounding client rect, and then now we want position. We need to take e dot client x. We need to take so client x is the position between the entire window for the view, the viewport, and then you gotta subtract the canvas x to get it relative to the canvas, and then you're gonna do the same thing for the y. And then we can set our this dot mouse pass is equal to new vec2. It will be pass x, pass y, and now we can draw another polygon. Let's do polygon B. We can create that here. Polygon B, position will be mouse position. If we can start it, we can start it at maybe, let's say 100. And then we can just update it. This dot polygon B dot position is equal to this dot mouse position. Yeah, we can just use the same geometry, but we can rotate it. Right, we can just do rotate maybe by 50 degrees, 45. Okay, I'll draw the other polygon as well. We can say polygon B, polygon B. Yeah, we should be able to move it with the mouse. Perfect. So now we will do the test for both of them as well, along with the points. All right, so now let's do the implementation for our polygon collision. So if you remember from our last video, the overall routine looks something like this, right? So we want for all axes, this includes polygon A and polygon B's. We want to project each polygon, right? And then we want to check if there is overlap. If there is overlap, if there is no overlap, we can exit early and return false. So if we found an axis that doesn't have any overlap in the projection, there's no collision. All right, so we can just exit early. So this just makes it easier, like if you have a lot of different polygons floating around the screen, doing a simple check, like doing an early return, it helps with the performance. So you don't need to loop over all the axes and project the polygons. All right, so let's start writing. So we first need to get all axes, right? So I want to be able to say for const axis of a dot axes, right? So let's go implement this. Now let's write the algorithm first, structure, and then we'll go implement the helpers. So we go over A's axis. Now we want to project polygon A. So we want to have a function called project. And same for B. We want to project that as well. We want to pass it our axes. And then we want to check for overlap. If there is no overlap, we can return false. We want to do the same thing for B's axis. So it's the exact same thing. It's just B's axis. We could also combine it here. But I didn't want to materialize a whole array because I wanted to just write these as iterators, or generators rather, because it'll be pretty neat not to have arrays in here. Let's see. Okay, let's start implementing these helpers. I'm gonna go to Polygon. Let's just split a window here. Okay, and then in here we will go to Collider. Okay, so in here we had our edges. Yeah, so now we need axes, right? So we can also have that as a generator. We will say generator. It will be just a vector, because in here we are going to be returning the edge normals. So we take every edge and we just get a normal from it. So we will do for const edge of this dot edges. We want to say const normal, or let's say perpendicular, equals new vec2. You just negate one component, and wait, so edge actually is not one vector, is a combination of two vertices. So if we first need to compute the edge vector, we will say va dot sub. Do we not have subtract? Okay, let's go add that first. So we will first go to vector, add, we will do sub. Okay, now we go back. We will say va dot sub vb. Now it doesn't really matter if you do vb dot sub va. So one will give you the perpendicular that goes outwards of the polygon, and one will give you that goes inward. For SAT, it doesn't really matter because as long as you have a normal, the projection will be the same. Because we're just going to check overlap, so it doesn't matter which direction it goes in. Okay, we got edge dot y, we'll do edge dot x. Yeah, we flip the x and y axes, and then we negate either of them. That way we get the perpendicular. And then we do, yeah, we just yield perpendicular, right? So that way we get all axes. Now we need to write the project function. So we will say project, and we'll take axis. Axis will be vec2, and this will just return. We just need a min and max, right? So let's create a new type called projection, and we can say yeah, it's fine. We can create it here. We can say export type projection equals. Does it need to be an exported value? No. Yeah, it will just have a min and a max. So in here we need to go over all vertices and then project both polygons. Project that vertex with the axis onto the axis, right? Okay, let's see. So we want basically this entire thing. Can I move that out into its own generator? So I will say vertices wrapped, right? Because we are also looping back to the first vertex, so it's a complete loop. And what are we returning here? Well, in this case we just want to go okay, we want to return just one vertex, so it could be just this. We can fix the return type, and we need to make sure, because right now it's just going to the last vertex, we need to get to the first one as well. So we need to say starts at 0, goes to the length plus one more. Okay, and now we have the vertices, so we will go back to our projection, and then we will say for vertex of this dot vertices wrapped So we want to track a min projection, so we will say projection min is equal to, we'll start with the biggest value, so we can use infinity for that, and then now we need a max, and for that we can use the negative infinity, and then we will start projecting each vertex. So we will use the dot product. We will say proj equals vertex dot dot. Okay, we need to write the dot product. So let's go to our vector class, write a new function that does the dot product. It will be other and it will just return this dot x into other dot x plus this dot y into other dot y. It will just be a number. There we go. Now we do the dot product with the axis, and we need to check if proj is greater than proj max. We need to update proj max to proj. Do the same thing for the min. Right, and so we individually track the min and max. Yeah, if you remember from the video, you need to do the min and max because if you have some sort of rotation on the polygon, you want to have like the projection of that polygon, you want to the widest possible projection, right? Because that's what you want to test against the other polygon's projection. Okay, so now we got that, we need to just return min is proj min and max is proj max. Right, we need to give one more function called is overlapping. So if you have two projections, we want to verify if there is any overlap. So let's export that here as well. So we will say export function is overlapping. It takes projection A and projection B and returns a boolean. So we can say what is the condition for when it's not overlapping. Yeah, so if let's say a dot max is less than b dot min, that means I'm not overlapping, right? Yeah, I think it's easier to understand with the not. So if my if a's max is less than b's min, that means a comes before b, right? And there is no overlap. And we need to do the same thing for if b comes before a. So we will do b dot max is less than a dot min, right? And we negate the whole thing. I mean, now you can get rid of this one and switch these to greater than, and then switch the or to and also. You can also do that. That's the same thing. So you can say, for example, remove this, change this to greater than, change this to and, change this to greater than. To me, I like the first one more because it's more readable, and that's the way I understood it, but it's the same thing. Now let's go back and we will import this function. Okay, now let's try this out. I think that's everything for the SAT itself. Okay, we got all reds. Okay, perfect. What are we doing wrong? We did proj A, proj B. Check for overlap. Okay, I just debugged the issue. It was just I in the min calculation or the projection, I just copy pasted from the max. I forgot to flip the sign, flip the operator. And yeah, after changing that, we get back this value here. So this just means that around this triangle there are some squares that you can see. Let me zoom in. So these squares are the ones that are testing against this polygon. Now let's add our floating polygon to test with this fixed polygon and then see if it is colliding. We'll just change the colors or something. So let's do yeah, okay, we can do draw the first polygon and then let's move these at the bottom so the colors are not impacted for anything. And I will say if our polygons colliding, this dot polygon A, this dot polygon B, then we will draw our second shape but change the color. We'll just change the color. We'll say context dot stroke style equals green, or let's say, yeah, sure, green. Now let's see, is white. If I bring it close, well, that didn't do anything. Maybe is A the fixed one, B the floating one? Yeah, so okay, I'm doing something wrong. Stroke style is green. Does draw shape bring back the color? Yeah, it does color dot entities. Okay. I don't want to have that here. Yeah, let's get rid of that. Does this take effect now? It does, but it changes the stroke on everything. So what I want to do is I want to go to each entity and then set the color there. Oh, it is set here. So close path stroke restore. Where is the player? Does it do that as well? No. Okay, so let's do that. We'll do context dot stroke style is equal to color dot entities. Import the color. Yeah, okay, that's fine. Now you can see that as soon as I touch this polygon with the fixed one, we change it to green. Perfect. And that's everything for the polygon-polygon collision. One thing to remember with SAT is that you need to ensure that the polygons that you are using are convex. And there's a difference between convex and concave or non-complex polygons. The quickest way to show you would be just me to Google it. Let's say convex versus non-convex polygons. Yeah, so if you can just take a line from one point of the polygon to another, and if it doesn't cross any other edge, then it's a convex polygon. Concave polygon would be something like which has a hole, sort of like a hole. So you see, like, you could take this point and then this point, but it crosses other edges in between. So SAT only works with the convex polygons. So what we're gonna have to do is, so if you're using, I think some of the asteroid shapes are using some complex shapes, we're gonna have to split up our asteroid shape into multiple convex polygons and then test with each of those as a group. So we can do that next time. It's gonna be pretty simple. What we're gonna do is we're just gonna store a collection of polygons for asteroids rather than just a single polygon, and that's it. We just test against that collection each time. Okay, I think that's pretty much it for this video. Next time we will wire it up with the asteroids and get those collisions working. Okay, thanks for watching. See you next time.